this webcast as well. So thanks again for joining me for this webcast. So today we're going to talk about CircuitWorks, which is part of the SolidWorks Premium offering. It allows you to interchange data with your ECAD programs. And we'll have a very brief overview of the product. I think you'll be excited to use the product if you don't already use it. And if you do use it, I think you'll get a few nuggets of information that will help you use it better. So, in dealing with companies that do electronic product design, I kind of made this funnel here, and I break it into 3 different balls inside this funnel for what electronic product designers care about. So first of all, there's the electrical aspect of your design. A lot of people will use an ECAD package for this, like Altium or PADS or Eagle. Some people have SolidWorks Electrical now for doing more of the high-level stuff, not the detailed circuit board level stuff. So we're not going to talk about the real high-level stuff today, but this is an aspect of what people care about. The secondary aspect of packaging is packaging design. So as you deal with circuit boards, you obviously need to fit these in confined spaces, as you can see here. If you take a look at the screen here, we have the package design. And you have your housings, sheet metal enclosures. They all need to fit into a confined space with a circuit board. And obviously, because you have the 3D information, you'd be able to run a thermal analysis to make sure you're dissipating heat through that. And then finally, the third part of electromechanical design that I see is the actual PCB design. And obviously, SolidWorks isn't a proper circuit board design package. It's not going to create the traces automatically and auto-route things. But very often, you need to interchange data between systems that are specializing in that field of work. As you can see here, a lot of people will use Mentor Graphics Power PCB or Expedition, PADS. Altium Designer is very popular, as well as OrCAD. And finally, Eagle is becoming quite popular as well for doing PCB layout and schematic capture. So CircuitWorks is what will help you interchange this data. So why the heck would you want to even consider interchanging your ECAD and MCAD information with each other? Very often it's 2 different people in the company. But on the design side of things, on the mechanical side, very often it's a form and fit type of question. You have complex board shapes as products are becoming more and more complex. You need to position critical components, push buttons and things like that, screens, connectors. These are all things that need to be laid out mechanically and fit in correctly. There's also the need to define these keep-in areas or keep-out areas. Zones where either the mechanical or the electrical team need to stay in or out of. And those could be critical in the collaboration between mechanical and electrical. Finally, people want to import boards back into SolidWorks from ECAD. So a lot of people will actually create a DXF file, just a 2D shape, and export that information into your solid model and extrude it up to the board height. But we're proposing a different way of doing that, and that's what CircuitWorks will help us with. Other reasons for linking ECAD and MCAD are doing the actual analysis. Doing a thermal model or an electromagnetic analysis is very possible once you have the 3D model. And even getting a nice visual rendering. If I go back to my first slide here, you'll see a nice rendering of a circuit board, and this might be critical in persuading your customers to purchase your products. So I'd like to go through a quick top 10 list of the things that I like in CircuitWorks that will help you create better designs inside of SolidWorks. So the first thing I'd like to talk about with CircuitWorks is the graphical preview of the printed circuit board. So if you're a mechanical guy, this is actually quite handy. You can actually see the PCB board before you even bring it into SolidWorks. So let's go through and do that. And let me just close that out. Go back in here to SolidWorks. So I have this nice circuit board here in SolidWorks, and I have several parts here in my tree that represent all the critical components of the circuit board. How did I get here? So let me close this file out. And I'm going to open up CircuitWorks by going to the pull-down menu inside of SolidWorks, and I can go ahead and open up an ECAD file. So you're not going through the normal File Open menu. If you did that, you'll actually see an IDF option in this list, and that is what we call CircuitWorks Lite, which actually comes with every seat of SolidWorks, and it will bring in a circuit board file of a certain type. There are 3 different levels of IDF, 2, 3, and 4. This will bring in IDF level 2, which is really just the board layout, the component placement, and the keep in and keep out areas, but nothing beyond that. And it also creates it as one big solid file, so it's going to be a big file. It'll perform poorly if it's a large circuit board. So what you really want to do is, if you have SolidWorks Premium, is to turn on that add-in, and you'll get this CircuitWorks menu, and I can open up that ECAD file. And that way you get more choices here at the bottom of the screen, as you'll see. And everybody can see that, I'm sure, right? So I'm going to go ahead and choose an IDF file type. You can see there's IDF 2, 3, and 4, and there's other file types which I'll get into shortly. So let me go ahead and open up IDF 2, and I'll choose a simple sample. And it's going to take a look at this file here and give you a nice preview of that circuit board. And this is one of the examples that comes with the software. So if you have CircuitWorks, you'd be able to go to File Open and get this same circuit board. And if you look at this, it gives you a nice preview. I can make that full screen because it kind of makes itself its own application running inside of SolidWorks. And you can see it gives you a nice feature tree on the left-hand side, breaking out the different components. All right. Even at the feature level, it's, here I have 54 plated holes on this circuit board. I have 10 non-plated holes. It's a one-layer board. Here's the actual board outline. And here are all the components that reside on the board. Now, there might be some components that reside on the top side of the board or the bottom side of the board. So you have a nice preview tab here. It gives you a command manager at the top of the screen. As you can see me kind of hovering back and forth at the top. And I have a preview, and I can look at the top view or the bottom view. So I only have one other component there, C2, on the bottom. So that's the reference designator of the component. And it just places it as a centroid of that component. You can also zoom in here if you had lots of stuff going on. This is a pretty simple board, but I can zoom to an area and see what was happening in better detail. And of course, panning around would be an obvious thing you'd want to do. So the preview is really quite a nice thing that is offered with the CircuitWorks. Even if you didn't need to do anything with the file, you'd be able to see what the heck was going on with the component. Now, on the component tree itself, you'll see that there are 23 components on the circuit board. And some of them have build symbols on them, and others have warning symbols on them. So if I did a zoom to fit here, you'll see that LTP right here, this particular component, is actually kind of not filled in with a nice blue filling. And that means that it doesn't have a Z-height value applied to the component. What that means is that in the ECAD program where this originated, there was no value assigned for the height of the component. Some ECAD systems are 2D, but they give you that piece of metadata so you can build the component up as a 3D object through this IDF file format. So if we take a look at that, I can actually adjust that right here. If I right-click on this, I can go to the properties of this, and you can see that there's a height value right here in millimeters. And I can actually give it a height of 5 millimeters right here, and it fills it in. I could also do the same thing for this component right here, FID Mark 1. I'll call that 10 millimeters high. Oh, actually, that's kind of small. It's going to be 2. Same thing for the other one. So now, we don't have any warning symbols left in our tree, and I would be able to build this in SolidWorks. What I'm going to do here is just save this really quickly as a new file here, example 1 with Z height, just so I don't lose that information. All right. Now if I go back to my slideshow here, that's number 10, the graphical preview of the printed circuit board. As you can see, you can even see traces and vias in this preview as well if you have a file that supports those features. So what I'll do here is go through some of those powerful filtering capabilities when you have a complex circuit board. So I'll go back to my CircuitWorks menu, and I can actually close this particular file. I'm all set with it right now. And without closing the CircuitWorks window, I can go to the upper corner where there's an orb here, and I can choose Open and browse to different files. So I'll go ahead and choose an IDF Format 4 file, which is a newer format that some vendors support, not too many. There's a couple of Japanese vendors that support the IDF 4 format. And what it is it supports more features. It supports traces, vias, and other types of things that you'd find on a circuit board. There is also another format that I'll talk about that's more common that will bring in the traces as well, but I'll get there later in my top 10 list. But if you notice this, if I were to build this board in SolidWorks, it might take me 5 or 10 minutes of processing time on my computer to actually build this automatically, because it's a very large board with lots of features and all the traces and everything. Maybe we don't need all of the information. We just need some of the information to come in. So that's what the Tools menu here is for at the top of my screen. And there's a whole area here for filtering out or in certain types of components. So if I go to Traces here, I could actually filter out traces that were narrower than a certain size. I don't want to see anything narrower than 0.5 millimeter. And you see what it did? If I check that or uncheck it, it might be hard to see on the GoToMeeting, but you can see that it kind of puts them, it grays them out a little bit. So what that means is it's not going to build those components in 3D, and it's not going to show up here on my screen so I can see what I'm looking for a little bit easier. So all of the filter capabilities are set depending on the type of feature it is, like pads, traces, filled areas, outlines, plated holes. So if I go to plated holes, I might only want major plated holes, so I can say just show me the holes that are larger than 0.5 millimeter. And it doesn't look like there are any. Okay. So filtering is a great option here. If you like these filter settings, you can actually export that as a file that you can just read in any time. So if you have specific things you want to filter out every single time you work on a board, just save that out as a file and then read that in as a filter setting file. And that obviously can be stored centrally if you have a team of people working with a PDM system. Hopefully that makes sense. Filtering. Number 8, we support all IDF information, and that's kind of a little bit of what I was just talking about. IDF version 4 supports the traces, vias, filled in areas, but we also support the keep in and keep out areas as well. So let me open up another file. So actually, this one right here has a keep out area, but let me find a different one that's a little bit more clear. I'm going to open up this particular file right here. All right. So in this file, there are some component keep out areas that I cannot allow certain electronic components to live in that certain region. So if I look at the properties of that, you can see the owner of that is set to ECAD, meaning mechanically we're not allowed to place any components in that particular area. It gives us the thickness of that area, so it's a 3D rectangular box, 2.54 millimeters high, and it's on the top side of the board. And you can see the start height and end height is defined. Now I can't see anything in 3D in this preview window, but I will be able to see it in 3D when I build the board in SolidWorks. So let's build the board. And that warning message was indicating to us that there were 3 components on there that didn't have a Z height value. That's why they're transparent there on the screen. So it built that board. It built it fairly quickly because I had already created some of these components in my library, which I'll get to. But you can see there's the actual board, and you can see the outline, or the keep out area is this transparent thing here, preview PCB, and you can see it's called place keep out. So all these names are actually quite important to the system and making everything work correctly. So that place keep out is part of our help system. If I did a search, I did CircuitWorks name on CircuitWorks IDF export, let's see. There's a nice list in the system here that shows you exactly what these names should be. I know I have a slide later where I'll show you that. But those names, place keep out, if I look at the board itself, the preview PCB is the name of the board. You can see the layers are named something special. The board outlines are named something. Vias, non-plated through holes, NPTH, plated through holes, PTH. All those names are things that CircuitWorks is looking for, and assigns a certain color attribute. And when you export stuff from SolidWorks, it'll actually build the IDF file in the correct way so that the receiving system knows what to do with it. But as you can see in this particular board that I have here, it is supporting quite a bit of information. And this is actually a native pads file that we're working on, which fully supports all of the features of what is similar to IDF4. So number 7, importing native pads files, is one of the great things for using CircuitWorks. I find pads in use the majority of our time in our customer base. And if you happen to have pads or have legacy files in pads, you're going to be able to bring those in their native ASCII format. So just like I did there, I imported the pads file. It supported all of the features. And that's new in SolidWorks 2013, I believe. And I've been alluding to this already, but importing and exporting is also an option. So if I were to make a change mechanically, and I want to let my fellow electronics engineer to know about this, I can make a change and export it. So I really need to move one of these components. Maybe this is a connector, and I need to move that slightly. So if I right-click on this, the best thing to do is to use this Move with Triad option. If I right-click on a part in my assembly, I get that. And I can just slide this over wherever I need it. All right. So by sliding this over, there's obviously vias here that need to go along with it. I'm not going to move those vias over, although I could. The ECAD program is better suited to handle that because there's auto routing and of the traces and other metadata it needs to update. So I'm not going to worry about that. The electronic engineer will worry about that. So I'm going to move my component, and I'm going to save this as, not using the normal Save As menu, but the CircuitWorks menu to export this to CircuitWorks. All right. And the cool thing that it does is it puts us in a compare mode, and it shows us what happened graphically between these two models. And if I look at the bottom of the board on each of the views, you can see that J1 has indeed moved. It even tells us in this list right here at the bottom of the screen that the component has moved by 9.42 millimeters. Isn't that great? So if I want to save the new file, I would just do a Save As. I'll say yes to export that information, and I can save it as native pads, or I can save it as IDF file if it's going to another system. And most other systems allow you to import an IDF file. Sometimes it's an additional module that you have to buy from that vendor, but you would be able to import that IDF file like so. So I'll just CircuitWorks moved J1, I'm going to call that. And that's how you would send that file back to the electronics engineer. They would open up that file and perform their work to make sure all the routing of the circuits is up to date and that everything's okay on their side. Now you can, from scratch, actually create boards and bring them into CircuitWorks to export into other systems, believe it or not. And this is quite handy, especially as you have really complex shaped boards. So if I were just to open up a brand new part in SolidWorks and draw a board shape, and you know, the sky's the limit with this. I mean, there's lots of different shapes that need to fit in different areas. You know, I might even need to have a board that looks like this. Let me just clean this up here. And I'm going to trim this up. All right, so that's the shape of my board. Now that would be pretty difficult to do in most ECAD systems because the tools for drawing are not as easy. Because SolidWorks has a parametric sketcher, I can model this very quickly. So I would just go ahead and extrude this as a certain height. You know, I'll call it 2 millimeters and say OK to that. And there's my actual circuit board outline. So you can rename either the sketch or the feature to board outline. And it could have a number next to it if there's multiple layers. But I'm just going to call it board outline. And I do want to find that item in the help under CircuitWorks here to show you the names of the features that are required. I can find this so easily usually, but mapping CircuitWorks, I think that will help us. There we go. All right, so if you do a search for CircuitWorks mapping, this is the actual name you want to see in the feature tree, board_outline. So I'm going to copy that and paste it right in here. So that's going to be called board outline. Now I'm going to save this part. I'll just throw it on my desktop here and call it the PCB. And I'm going to insert that part into an assembly. All right. Now I want another component on it. I might have some kind of custom connector. So I'm going to insert a brand new component here. I'll drop in a sketch. And I should have created a new part first. Let's do that. Insert a new part. Tell it to be placed on the top of the board. Insert my custom connector. Extrude that as I see fit. There we are. That's our new part. And I'm going to call that the name of a component. J1 might be the name of that particular component. But the name of the feature also needs to be updated. So we're going to have the actual component outline right here be the name of that feature. And obviously I just want to change the color of this so we can see it a little bit better. All right. So I'll save this assembly. It's going to be our PCB assembly. And it has all the ingredients necessary to actually export that to CircuitWorks. So if I go to CircuitWorks here, I can export that to CircuitWorks. It will identify the orientation of the component, so I can actually select the top face of the board to help orient it. And you can see there's my component right here, R1 that it called it. I really should have called it R1. But where is my board outline? Oh, here it is. So it is picking up that it's 2 millimeters. I could tell it to use an existing board, but I must have screwed something up here. Let me just save this as an external component as well. I'm not sure if that matters. That's board outline right there. And I'm just going to rename this to feature. Here we are. Just did this before the webcast on a brand new part, and it seemed to work fine. It is seemingly finding that that outline right here. I can see a piece of it. I might have something wrong with my sketch. I'm not going to belabor the issue right now, but really this process is pretty much the process that works for that. Right there. I'll worry about that later, and when I upload the recording, I'll make sure that's something, yeah, I'll try to figure out what went wrong with that. But if I were to open up any other component like this particular board, you'll see that there's a board_outline feature. This one is actually a 6-layer board. That's why you see 6 board outlines. Just one more thing to check. If I just open up the part by itself, you can also export this to CircuitWorks. And I'm not quite seeing the board outline there either. So there's something up with the sketch. I'm sure I must have left something in there that wasn't proper. All right. So that's number 5, creating stuff in SolidWorks and exporting it out to another system via the IDF or native pads format. But what about, all of this importing and exporting? That could get tiresome after a while. So that's why there's this new format called IDX. This is sponsored by an association called ProStep. They're actually responsible for the step file format that we know and love for exchanging mechanical information. But they've also come up now with this IDX format for collaborating between the MCAD and ECAD world. And how this works is it's almost like a data management collaboration tool where a user on the MCAD side can design their file and maintain a link to the circuit board information on the ECAD system side. So if you're using Mentor Graphics Expedition, let's say, which supports the ProStep format, you would be able to see changes happen in real time between the ECAD and MCAD system. So there is a video that I have on this because I don't have pads on my system or Mentor Graphics software. So what you're looking at here, if I pause this for a moment, is we're in Mentor Graphics Expedition PCB software, and we have the board outline for a PC, for a battery charger. And on the right-hand side of our screen, we have a collaborator window. So this is the ProStep Collaborator software plugin for Mentor Graphics Expedition. And this will help form the baseline of the printed circuit board. So as you design the circuit board in Expedition, and you leave this collaborator turned on, it's showing us all of the things that are on the board. Now, what we did was import data from the mechanical system and accepted those changes, and then it brought it into Expedition. And now we can actually, in this application, place components in Expedition in this particular case. As you can see, we're just placing parts from the library. So once they're all placed, these are now new, and the mechanical team then needs to be alerted. So you bring up the EDMD collaborator, and it will actually identify the components that are additions to the board. And the send button will actually then alert the mechanical team to this particular change. So to turn this on inside of CircuitWorks, so I'll just go to my SolidWorks menu here and go to my CircuitWorks options. There is an EDMD option in my CircuitWorks options. By the way, there's tons and tons of options here. We actually have a one-day course on CircuitWorks that we're running from all of our offices at CAP Inc. Even taking it on the road, I'll show you the schedule at the end of the webcast. But if you take a look at this, you turn on the ProStep module, and you define a shared folder. And this is what everybody would be connecting to share information between the ECAD and the MCAD. So the ECAD system, in this case, Mentor Graphics Expedition, would also be pointing to the same shared folder for its data exchange. And you could actually have an email be sent back and forth to let's say, ProStep at yourcompany.com. So you'd set up an email address that everybody would subscribe to, so they could see changes happen via email, or every time you open up the file, you can check for changes made before applying the changes. So you turn this on, and it allows for a more interactive data exchange session. So that's what that's all about. And that's my 5th favorite thing in CircuitWorks. And I already talked a little bit about number 4 here, comparing and showing changes between the two files. So if you made a change or you got a changed part or circuit board from our friends in the electronic team, you'd be able to see exactly what changed. So we already showed you that, so I won't jump into that right now. But very easy, just open up 2 files at once and do it. Let me just show you that method because it's actually quite interesting. If I open up an ECAD file, and I'll just open up the first one, you just go to the menu here to open up another file, and you can open up the second file like so. And it gives you the ability to hit compare at that point in time. And it shows you everything that's different between the 2 files. Let me slide this up here. So there's the component that moved. I skipped number 3, so I guess there's no number 3 in my presentation. But number 2, I really like this one. It could make up for not having a number 3. Being able to annotate the components in SolidWorks based on the information from the ECAD file, most notably the reference designator information. So once I have a board in SolidWorks, and I'll open up my previous one that I had built. This one right here. You're going to notice they have all the reference designators listed here, R5, U5, U2, Q1. And that information is actually stored as property information in the SolidWorks file that gets built. So if we look at this, we have the circuit board, and it might be handy to actually show the reference designators. Now, you can show them on the CircuitWorks feature tree that is available once you have the software turned on. You can see the names of the components and the multiple references of each of the components right here. So you can zoom to that selection to see exactly what that component is. All right. It might also be nice to actually see it displayed just like it was in the preview, though. So on the CircuitWorks menu here, we can annotate the components with the reference designator, and we can tell which side of the board we want it to add it to. In this case, the bottom, because we're looking at the bottom of the board. And you can see there's the reference designator on there. Something's not happening with my GoToMeeting software. Let me just turn on the annotations here. Let me just try to get on the top level components. Looks like we're getting them in here now. So you can see there's X1 on that particular component. And that information will also be available if you happen to make a detailed drawing of this assembly. So I just told it to save the PCB file, and it's going to open up a drawing for us. There we are. That looks beautiful. So we can lay out a nice detailed drawing and call out certain components now in SolidWorks. So to display the annotations, I could go to the details here and make sure that my model items are turned on for those notes. So I insert model items and tell it not to bring in dimensions, but for the entire model, bring in the notes. And there they are. It just places it on the center of all the components. Now you might want a display state of the keep out area hidden. Let me just hide it from here just so it's easier to see what's happening underneath. Obviously you might want to hide the other layers. It actually might look better in shaded mode here. So you can see things a little bit easier. So whatever your preference is there. Now some people don't like actually seeing the those notes kind of one on top of the other because it gets kind of messy. They don't actually stick to the components if you move the view as well, so you got to be careful about that. So there's another way of displaying those notes. So I'm going to delete them, and I'm going to call them out with balloons. So you can do an auto balloon of a printed circuit board assembly, and I can tell exactly where it'll live, right up here. And rather than showing circular balloons, I'm going to just put an underline here and make it a tight fit. And you'll notice that we got item numbers right now, but I'd rather have it show the reference designator. So for the balloon text, all you have to do is choose the component reference. Isn't that great? Hopefully that was worth the waiting through the webcast. But a lot of people ask me that question, how can you identify the reference designator on a drawing? And this is how you would do it, one of the ways you would do it anyway. All right. Of course, that could be done in any other view. When you throw a bill of materials on here, I'll just throw a general BOM. So rather than showing item number, I would double-click the column and choose the component reference instead. That just makes more sense for a circuit board or anything electrical, electronic in nature to call that out instead. Excellent. And they get certain colors by default. We go through that in the course when we teach the software. But the number one reason why CircuitWorks is very powerful and is this component library that it's building. You notice how quickly I was able to build that board from scratch. When I said open the pads file, it built it without really taking too long. And it's because of the component library. So the library is built as you start generating components. If I go to the CircuitWorks options here, you're going to see that when I'm importing files into SolidWorks, I'm having it throw the components and the boards into a central location. In this case, my vault, my cap vault. And it's actually creating a new part file every time it sees a component. And if it sees the same component over and over again, it's just going to, use the one that's already in the library. And it's all managed by a SQL database. I have a SQL server on my system that I have everything being added to. But it also comes with a SQLite database if you have a small work group of people. But if you have a large work group of people or you have SQL Server and you want to get the benefits of using that, you can attach to an existing one. So the library that it's generating, you can actually look at the library all by itself under the CircuitWorks menu. It's going to show you all the parts that it's made from the component outlines. But you can also have it, you can replace any component with the real component that you might get from your vendor. So, this component right here, PIL 16R8, that component right there is a blocky kind of outline. It doesn't really represent what the part really looks like. So you could edit that component, just right-click on it and say Edit Component, and browse to a different file that better represents that part. And let me just take a quick preview of that. Since I'm using EPDM, that might actually be a better representation of it. So I'm just replacing that with that component. You can tell what the default root is for the reference designator, what the height is it read it from the book. Say OK to that. Now that's going to be the actual component that it's going to use the next time it sees that component name as called out by the ECAD system. So wherever you like to get your parts, you get to change the part that gets built every time to be a better representation of the part the next time it builds the file. Excuse me. So the component library, the best reason for using CircuitWorks, and of course that can be a central option. So we do offer a course that lasts about a day for CircuitWorks. It goes over a lot of the stuff that I covered today. Obviously, I went through this very quickly. But we talk in great detail about the parts. We actually encourage people to bring your own PCB files with you when you come to one of our training classes for CircuitWorks. But this is an example of the syllabus for the course. And here's a listing of the upcoming CircuitWorks and other electrical-related activities that are happening at CAP Inc. over the next month or so. We do have an electrical routing class if you're doing just wire design. We have a class that's one day for that in Peabody. We have a CircuitWorks class in Westboro coming up, as well as in South Burlington, Vermont in April. We have a new mobile training lab that we're taking all over New England, and that's where we'll be doing one of our classes up there. We also have our SolidWorks electrical software for doing the actual schematic design for large-scale electrical systems. Not covered in today's webcast, but you've probably seen some stuff out there about SolidWorks electrical. So we have schematic training and 3D electrical training coming up this month in Westboro as well. And if you haven't seen SolidWorks electrical before, there's a hands-on test drive. If you're interested in getting your hands on it in a free afternoon session at our Westboro office on Friday the 22nd. So I hope you enjoyed the webcast today, and it showed you a few things that you might be able to do with CircuitWorks. I encourage you, if you're an avid user of CircuitWorks, to sign up for some of our training events that are happening. And I really do appreciate you bearing with me for screwing up the time a little bit. I hope you found the webcast valuable, and look out for a recording very shortly on the software. If anybody has any questions that are still on the webcast now, feel free to hang on, and I'll wait a few minutes before closing the session. But feel free to enter any questions in the questions panel on the right-hand side of your screen in the GoToMeeting interface.